Our, our next speaker is going to be Ed Hudgins. He's a director of the Atlas Institute, which is a libertarian institute, and Ed is a leading libertarian intellectual. And so he has ideas on how human expansion into space will increase human freedom and how human freedom will increase human expansion into space. So
We're going to start. Hi, I'm Edward Hudgins from the Atlas Society. I also used to work at Cato and the Heritage Foundation. I did this book, Space, the Free Market Frontier, for those of you who are into, well, free markets and frontiers. I assume most of you certainly are into the latter, if not the former. And what I was going to speak about today is a kind of an interesting topic. The singularity and space is what I've titled this. And I want to start, I'm not going to be talking so much about science, but I want to start with a couple of big thoughts. Okay, big thought number one. We can engineer the environment of Mars to make it suitable for human biology, or we can engineer human biology to make it suitable for the environment of Mars. Kind of a big thought. Big thought number two is we could bring to Mars the same violence and pathologies that have plagued human society and that arise from the irrational aspects of human nature, or we could tame the irrational aspects of human nature to vanquish them from Mars' violence and pathologies and create a society in which humans can flourish. In other words, do you want this or do you want this? Now, what I'm going to suggest is this. There are two revolutions in thought going on right now that make these thoughts relevant rather than utopian. I don't believe in utopias and perfection and heavens on earth and stuff like that. But there are a couple of things going on right now that I think we, as folks who would like to see Mars colonized, have to take cognizance of. First is the exponential technologies that are going to be leading to enhanced human capacities and longevity, and perhaps even, as some people like Ray Kurzweil suggest, a singularity. The second, that gets a lot less attention, is brain science and neuropsychology that is more and more explaining behavioral tendencies in human beings, but also allowing us to figure out better ways to control them so that we don't bring to Mars the pathologies that have plagued us all here on Earth. And so what I'm going to do is argue that, that Mars settlement will be against these revolutions, whether we like it or not. And our opportunity as kind of the vanguard that wants to set up Mars as a new habitat for humanity is to integrate these revolutions into our thinking so that we can be the vanguard of the next stage of the Enlightenment. Let's start with the obvious, what most of you I'm sure probably are well aware of, and that is that we have had exponential revolution in the information and telecommunications field. Moore's Law, as I'm sure most of you know, says that every 18 months to 2 years you're going to see capacity double. And this has been the trend for the last 50 years. And of course, what this has done is given rise to pretty much the world that we live in today, of PCs, of the internet, search engines, the cloud, immediate access to everything, constant change and progress, and of course the applications of these technologies to everything from adaptive optics to Mars rovers. We had an excellent talk the other day about 3D printing and manufacturing in space. And by the way, the 3D printing and manufacturing is going to create a commercial revolution in the next decade comparable to what Amazon and Kindles and so forth created in publications and in product delivery. Add drones to that, but that's a whole nother discussion I will not get into because I don't want to get, well, I will get political later, but that's another issue. Medical device is a fascinating area as well. I'm particularly fond of Dean Kamen's artificial arm. Dean Kamen is the guy who invented the Segway. He's a serial inventor. He was asked by DARPA a few years ago if he could make an artificial arm because veterans coming back with missing limbs basically got sort of a stick and a hook on it, and they've been doing that since the Civil War. That was not adequate. He's come up with an artificial arm here that weighs 9 pounds. He was told you have to make it 9 pounds or less. It has to be able to pick up a grape without crushing it, be fine enough to pick up a race, and that's pretty much what your parameters are. He did it in a year. There's the prototype. Absolutely amazing. People who hadn't had arms for like 30 or 40 years tried it and said, my God, I've got an arm. This is the application of these exponential technologies. I like Carlos Cameras made the smallest X-ray machine in the world right there. You can see that using these technologies. And George Whiteside, by the way, he's the father of the guy who most of you probably know has been very involved in space for many decades, did basically the diagnostic chip that's about this big, and you put a urine or blood sample, and you can do all sorts of diagnostics. It's that big. Of course, robotics working in hospitals. Let me mention, of course, robotics and artificial intelligence. We all know where that has been. It's in all of our computers, our smartphones, et cetera. One that I find fascinating, and this is literally in the last couple of days, one of the things that's been going on with diagnostics, especially with IBM and Watson, has been going through masses of data that humans simply can't process to look for patterns, diagnostic patterns. And now, this is literally within the last week or so, the CVS Pharmacies has teamed up with IBM to make this capacity and these technologies available basically to everyone. I mean, this is how fast it's going. The Washington Post, if you saw it here in DC, I think this was on Thursday, they did a review of this book, Humans Are Underrated, sort of looking at what robots can do better than humans. By the way, this is what the diagnostic stuff that Watson's going to do is going to not only look at diagnostic data, but it's going to be looking at, for example, brain scans, things like that, essentially photos, in order to do diagnostics. This is the kind of things that are happening right now. Nanotechnology, of course, is another area where you're starting to get the exponential growth. Of course, nanotechnology is in all of our phones, all of our computers. Nanomaterials has been a little bit behind in the last decade or so. This book on the space elevator came out, I think it was 2002 maybe, looking at the possibility of building a space elevator with nanocarbon tubes. The problem is they've had trouble linking the things together. They've got the things. The interesting thing about this book, it also was very keen to look at the economics of it. Too many people talk about, well, if we just give $1 billion or $2, we can do this thing. It actually looks at the economics of a space elevator compared to other means of getting into space. By the way, this was just in the paper about 2-3 days ago. You might have seen the Canadians have developed an inflatable, this is not an elevator going up to the stars, but it is something that goes up 20 kilometers. And they just filed a patent for it literally about 3-4 days ago. Just, you know, this is how fast the technology is moving. Nanotechnology, of course, is being investigated for medical uses. Imagine instead of having to do chemotherapy the way we do it now, you basically poison the body and hope the cancer dies before you die. Not a very good approach. Serious work, of course, is being done on trying to program nanobots that go in and just go to the cell that has the problem and turns it off, and does this by the millions. And, of course, genetic manipulation. Craig Venter, as you probably know, he's actually local here, had a lab in Maryland for $300 million. Private guy, basically decoded the human genome. The government said it would cost $3 billion and 10 years, and he did it for $300 million and did it in 1 year. Pretty good. The idea of if you can do genetic engineering, you can eliminate things like Alzheimer's, Parkinson's, and the like. And this is interesting too, because I mentioned economics are important, you know. And if you take a look at the cost per processing a genome, it started back in 2000 or 2001, I guess, at essentially $100 million. And then take a look at the costs here, where 2007 it was down by, this is logarithmic, by the way. It's basically down to $10 million from $100 million over a 7-year period. And then, wow, look what's happened. And the materials I've been reading is it's now approaching $1,000 to decode a genome. And what that means is you're going to see a lot, just as when you had the exponential fall in prices and the high and increase in processing speeds with computers and processing, you saw all sorts of applications. Now you're going to see the same thing with manipulating the human genome. Google's Calico is putting in, this guy right here, a guy named Bill Marist, has a $3 billion portfolio. He's investing in this sort of research. Peter Thiel, Page at Google, Larry Ellison, Bill Gates are all putting money into life extension research. By the way, this is the current issue. I have a copy of it somewhere right here of Wired magazine talking about how cut and paste genes now are, cheap enough that everyone's going to be doing it. I like this particular thing here. This thing is called a Hydra. It's like a 0.5 millimeter, and I don't know if you're familiar with this thing. It's this little doohickey you find in swamps and all, and apparently it doesn't age genetically. I mean, they die if it gets squashed or eaten or other, but apparently this is an organism that actually doesn't age. The cells in every other organism have a tendency to age. And serious research is being done about how does this thing work so it never ages? Because can we engineer our own cells so that we won't age, eliminating genetic processes that are killing us off? As many of you probably know, Peter Diamandis, who did the XPRIZE, co-founded the Singularity University with Ray Kurzweil, and they're dedicated to the idea of human expansion and to taking all of these exponential technologies and hopefully moving it towards what they call a singularity. And that brings us to the final thing on this part of the presentation. There's a group that many of you probably know about, the so-called transhumanists, who actually are putting money into, of course, life extension and human enhancement with the notion that someday humans and machines might actually merge. And again, this might sound like science fiction and utopia, but for example, there's been a mouse experiment done recently where essentially a command was taken out of one mouse's brain and put into the other, not stimulating the brain, but somehow feeding the information in. And of course, you can do this. You can actually do this with broadcasting. You don't have to put a wire in. You can essentially broadcast. And this is the notion of, can you download information at some point into human brains? And again, the science is getting serious with this stuff that might have sounded pretty fanciful. Ray Kurzweil believes someday in the next 20 to 30 years, we will reach this point. Now, by the way, I'm doing a piece for Skeptic magazine where I'm, skeptical, okay, about it. But the point is, all of this money and research is being done in these different areas, nanotechnology, genetics, and so forth. And like it or not, this is going to be the world that we're going to be living in the next 20 to 30 years as those of us who want to go to Mars and make it a habitat for humanity work these things out. This is going to be the background. Now, are there possible uses on Mars? Well, there's some short-term ones, obviously, or maybe long-term ones. Respiricides, as some of you might know, is the notion of having artificial red blood cells. That's the researcher who has done this. And so what if you were on the planet Mars and you didn't have to worry too much about oxygen, because you could put these nano things into you and they would essentially breathe for you, or they would do it in a much more efficient way. This has been a staple of science fiction in the last decade or so. What about radiation-resistant cells? What if we start having kids on Mars and saying, even though, of course, most of us here know that radiation is not a problem. I mean, you can ask Robert Zuper and he'll explain that to you. But for those of you, if they really were a problem, okay, well, hey, here's the way to deal with it. The notion of seeding Mars, well, of course, seeding Mars with something that will take in carbon dioxide and breathe out oxygen, well, why not some genetic engineering that really will make these things breathe out the oxygen and basically speed up the process of terraforming Mars. Of course, robotic everything. If you read most science fiction, people are going out and they're getting their fingers cut off and all because they have all sorts of problems. Well, with robotics, you basically can stay in the hab. I mean, you go out for recreational purposes, obviously, and to have fun, skiing on the polar caps or whatnot. But, you can do a lot of stuff remotely because you now are having the capacity for interactive robotics. So you have, and by the way, the economics is also very important. I'll get into this again a little bit later because, it's interesting. For those of you who read Red Mars by Kim Stanley Robinson, one of the things about it that's not very realistic is he has essentially manna coming down from heaven. All of this stuff is coming to the planet, and you say, who the hell is paying for this? I mean, maybe they've got a couple of rich sugar daddies or something, but, one of the things about this technology is that if you're going to go to Mars, it's not going to be manpower that you're going to need. It's going to be brain power. Ayn Rand had this great phrase I like, that a machine is a frozen form of human thought. The notion that this is what is going to be important on Mars. And so all of these technologies are really important. Now, at this point, if I were doing, you got about 5 minutes to go? Ooh. I have 10 minutes to go. Okay, well, I better move along very quickly. There's also, of course, some people who see downsides with this. You've actually seen Bill Gates, Elon Musk, Stephen Hawking question whether AI is going to essentially become our masters. What about genetic engineering? Can you think of nefarious uses for it? Of course. You can always think of nefarious uses. Are we going to create monsters? Are we going to have a new eugenics? Those of you should read Merchants of Despair by Robert Zuprin if you want to really look at the history of eugenics that was horrible on this world. Well, this brings me to the second revolution. We, especially those of us who want to go to Mars, have to understand that most human problems arise not from a lack of technology, but from the fact that we are creatures of reason, emotions, and moral sentiments. What we have to do is learn how to work not only smart, but with wisdom. This is where the revolution in the brain and neuropsychology has really come to the fore in the last decade or two. Steven Pinker is perhaps one of the best on this. He wrote a book called The Blank Slate, essentially saying we're not a blank slate. On the one hand, it's an absolute fallacy to believe that humans are infinitely malleable. We have a nature. Every attempt to engineer humans has ended up in failure, whether it's the Soviet Union or Nazi Germany or you name it. But it's also equally wrong to assume that we're completely determined by our biology, which, again, we are not. And, again, you can look at Pinker's book. I'll give you a couple of quick examples here. A very good book by Michael Shermer, Skeptic Magazine, has looked at all of the research on how the brain makes errors. It's not just that the people didn't take the right logic courses. There are biological things happening. For example, when confronted, this was a recent experiment, when confronted with contradictory data, for example, in 2004, people who supported Kerry and Bush they had two test groups, and they confronted them with overt contradictions that each of these candidates had made. And then they did an MRI on the brain to see what happens. It was fascinating. The dorsolateral part of the frontal prefrontal cortex that usually processes, that we usually do reason with, was quiet. The part having to do with emotions here and here was what was most active. In other words, what was happening is people were rationalizing, and there was a biological basis for this rationalization. Another guy, Jonathan Haidt, I'm going to move along a little quicker here, has done a lot of research looking at evolved hardwired capacities in human beings. And I can talk to you about more about this later, but this is very good empirical data where you look at, for example, we are tribal creatures, meaning that 100,000 years ago, it made sense that if your face didn't look like my face, you were probably going to bop me over the head, okay? And it had a survival value. So loyalty to the group was important. And you can actually see where this is programmed into us and probably falling on a bell curve about how much it is in each other. And what Haidt has done is a very good job of empirically trying to explain why people have certain political views based on how they come out on these measures. Absolutely fascinating. Well, on Mars we need to work smart, okay? And this is where these things come in. What we need is a revolution in education. in two ways. The Industrial Revolution model of education was good, but it doesn't work anymore. That is, where kids at 9 o'clock, they're here on the assembly line, and you pour history in, and at 10 o'clock, you pour math in, and so forth. That's not how children really learn, okay? And there's been a lot of good work based on empirical evidence of how to change the way we do education. Even more important is the need to integrate into educational training programs ways that we and our children can deal with these biases and these inbuilt tendencies. That's where a real revolution will, especially for people who are going to be living together on another planet, can avoid the kind of conflicts, the kind of violence, the kind of brutality that we've seen on the planet Earth, as well as to make sure that the technologies that we're going to be using there, like genetics and nanobots, are not used for nefarious reasons. We need to adopt a kind of an achievement ethic. I'm going to move along quicker here. The next phase of the Enlightenment, I argue, is going to be on the planet Mars, because it's going to be the next habitat for humanity. That we can use these exponential technologies and these revolutionary insights about how the mind works, not to create a utopia, that's not going to happen, but in order to understand our nature and to educate us better, and so that the planets and the moon are going to eventually be ours. I thank you for your attention. I probably only have time for a question or two, and then we can I've got time for a couple of questions. Okay, good. Anyway, aren't they beautiful? I mean, oh my gosh.
You used the word skepticism twice, and let me underscore that, because
Yes.
the one message that everybody in this room needs to know is that you should never take at face value the marketing of a Harvard professor, George Whiteside.
Yep.
That goes double
Yep.
for Craig Venter, and it goes triple for XPRIZE and Peter Diamandis. There's Richard Feynman has what we call cargo cult science. I
Yep,
prefer
I
to
know that
call
one.
it technobabble.
Yep.
So the second part of your talk is brilliant. The first part, I think we should discard as
Well,
marketing.
you know, it's funny because Michael Shermer, who I had one of his books
Right.
up there, you know, does interviews. He's the editor of Skeptic magazine, and people will say,
There
well,
you
how
go.
can you justify this, and why should we believe you? And his answer is, you shouldn't believe me, and you shouldn't believe me either.
But
By
let
the
me-
way, I do point out that Peter Diamandis did manage to get the XPRIZE thing going, and there was a prize winner, and it publicized private space, and it did a lot of cool stuff, and so, hey, you know.
We don't have enough time for a
That's-
serious discussion about how we're going to change human genetics to solve all the problems you heard about.
Which,
with
by the way,
princess.
as I say, I'm skeptical about it, but the work that is being done has a lot of fascinating applications, and that's what I'm saying we should
But
keep.
let me ask you
keep
to
on. Go
react to
ahead, yeah.
another comment.
Sure.
I mean, because you're a good objectivist. So, you know, you have this situation where when First World War showed that the inherited monarchy could not be trusted to rule in a world of dynamite, right? Because the DNA won't allow it. The hemophilia.
We
and the
blow
Russian
stuff up.
so on. Well, the DNA just fails. You have hemophiliac Russian Tsar parents, and you have Rasputin, and the whole place falls apart. What we learned, of course, was that humans replaced the monarchy by a non-monarch, Hitler or a Cromwell in the English,
Right.
who turned out to make himself one. And the American was the exception because the Americans had this independence streak
Yes.
coming from the pioneer culture.
Yep.
Would you not agree that this would be the same thing that would apply to Mars for the same
I would
reason?
certainly agree. And by the way, again, if I can refer to Robert Zuprin in some of his past Mars Society talks, and I'm sure these are, you can find these on the website, goes over details of the pioneer experience in the United States that, you know, most people don't even know about. That just, you say, my God, we've got such a wimpy, culture today. You know, people just, complain about everything. And you look at the kind of stuff that pioneers had to go through to found this country. The risks they had to take were incredible. It will be similar on Mars, and I completely agree with Robert Zuprin on this, but I would add that, again, the difference is that it's a different kind of frontier, and it's against the backdrop of the fact that we really need technology. I don't want to say worship technology, but that's really going to be what allows us to make Mars into a habitat. To take, again, if I had time, I'd say, okay, everyone break up into little groups and let's all brainstorm how we can use these technologies. But, other people are doing that, and they've done that for the last couple of decades, and that's where we have smartphones and computers and all those wonderful things. But the other thing, again, that I think is most important, I'm glad you sort of glommed onto this, is the insights into human psychology. Not that we are deterministic, but that we have to, nature to be commanded must be obeyed. And that goes not just in technology, but in ourselves. I had a picture of Aristotle up there because he's one of my heroes. I got a PhD here at Catholic University, and Aristotle, most people here are a big fan of Aristotle, and so am I. That, in a sense, it goes back 2,400 years, the kind of stuff we're doing. But the science has given us insight as to what's actually going on in there, how the brain is working, and therefore giving us insights of how to create educational training that will allow us not to have the pathologies that I pointed out here and that you pointed out. You have time for one more quickie? I think over here, and I'll try to answer quick too.
Hi. So you mentioned space elevators and carbon nanotubes, but I was under the impression that there's certain physical limits about mass versus tensile strength, and that carbon nanotubes are something like 1/10 as strong as they need to be to make that plausible at all. And so, there's possibly an absolute physical limit in the universe. Maybe it's just impossible to make a material like that, and it's just, I'm wondering how you can suggest that perhaps carbon nanotubes could do that when it's possible we won't for 10,000 years maybe.
Well, okay, for two reasons. By the way, again, I'm saying, what I'm doing here is not saying I'm going to necessarily put all my retirement money into this, okay? But what I'm saying is that, for example, read this book. I think it's a very good book that actually talks about those kinds of things. Now, you can actually go back. In fact, I was going to do this. I didn't have time to do it for this particular talk, but for some other things I'm working on, I was going to go through this book again, which I read when it came out. And the linchpin was how quickly they maintained that the tubes are strong enough, but the problem has been, and I talked to someone about this a couple of months ago, is linking them up so that they kind of stay together. There's a kind of a linking issue there. And so it may be that instead of 100 years, it may be longer. But I don't know. And that's, by the way, the final point I'll make is on Mars, we have different models for how Mars will be colonized. And first, it would probably be small little cooperative communities. But ultimately, you have to allow for entrepreneurship. Because, I mean, after all, that's where we have gotten all the things pretty much today. You can say, well, yeah, DARPA did some basic research on one thing or another. I've cited some DARPA research here. But it was basically people saying, hey, I got an idea. Maybe we can take and put this thing together and take all this stuff and make one of these guys. Or, I mean, these things haven't even been out for 10 years. And any of you who have an iPad, iPads have only been out for 5 years. This is the thing about human beings. We're individuals. We are creative individuals, whether we're nurturing a child to maturity or a business to profitability or writing a song or a poem or a business plan or a dissertation or laying the bricks to a building or arranging for its finances or designing it. We're all creators. And the way for society to flourish is we have to each be allowed to use our creative insights to experiment. Just as we experiment in science, you experiment in a free market. And you try this thing, and if it doesn't work, you try something else. Actually, it's funny because, as you probably know, Microsoft tried a tablet a decade or so ago, and it flopped. No one cared about it. You know, I think who was it that did the Newton? Remember that one? You know, it's kind of flopped, and it just wasn't its time. But with the advances, with the exponential growth in technology, at a certain point, this now became doable. But that's the importance of entrepreneurship, and that's what all planned societies lack, is there's always this central planning, and okay, we have to get consensus and all, but people have to experiment. So experiment with all of these things, and I thank you for your attention.
Our next speaker is going to be Art Harmon. Art Harmon is the former legislative director to Congressman Stockman, who was the congressman from the district in Houston where Johnson Space Center is. So he was heavily involved with the space program and the politics of the space program. And he's going to talk about the two-person Mars flyby mission, which perhaps Dennis Tito has backed out of, but it still could be the right idea and the way we can get our space program moving again. So